My dear students, in this video I am going to talk about electrolysis and products of electrolysis. This topic is from the chapter Electrochemistry. Electrolysis and products of electrolysis. Students, first time electrolysis has been done by two scientists. Their name is Nicholson and Corliss. In the year 1800, two scientists, they have done the electrolysis of water and they are able to produce H2 gas and O2 gas from the electrolysis of water. So, which is a non-spontaneous process. Electrolysis, a chemical reaction is carried out by using electricity. In the year 1800, Nicholson and Corliss, two scientists, has done the electrolysis of H2O, acidified water. Then later, 1830s, a scientist called as Humphrey Davy has done the electrolysis of molten NaOH and molten KOH. And from this he is able to produce first time elemental sodium and elemental potassium from this. Till that people were thought that these cannot be decomposed into the smaller atoms. Then Davy's assistant is a Michael Faraday. Humphrey Davy has done the electrolysis of in the year 1830s. Later Michael Faraday has given two quantitative relationships in the electrolysis, that in the syllabus we will study it as a Faraday's first law, Faraday's second law. Okay, Michael Faraday, right? Faraday has given quantitative relationship in the electrolysis. We will study it as a Faraday's first law and Faraday's second law. Quantitative relationships in electrolysis. Has been given by Michael Faraday. Students, first let us define what is a electrolysis. Electrolysis is a non-spontaneous process. A non-spontaneous process is a process which does not occur by its own. So it needs some external agency. Electrolysis is a non-spontaneous process in which ions are get discharged into neutral atoms or molecules at respective electrodes. So students, electrolysis is defined as a non-spontaneous process which does not occur by its own, which needs some external agency, and in which ions are get discharged into neutral atoms or molecules at respective electrodes. That is, cation get discharged at cathode, anion will get discharged at the anode, right? Electrodes are conductive terminals. Electrode which is connected with positive terminal of the battery acts as anode. Students, let us continue our discussion. What is a cathode? Electrode which is connected to electrode which is connected to negative terminal of the battery, negative terminal of the battery acts as cathode. Students, here cathode and electrode is not because of the charge, because of the reactions taking place. At cathode, reduction takes place. At cathode, reduction takes place. At anode, oxidation takes place. Oxidation takes place. Both the processes will occur in a single container. Both the processes will occur in a single container known as electrolytic cell. Electrolytic cell. In this, a non-spontaneous reaction is carried out by using electricity. And students, the electrode which is connected with the positive terminal of the battery will act as a cathode. Positive terminal of the battery acts as a anode, that is not cathode. Electrode which is connected with the negative terminal, of the battery acts as a cathode. At cathode, reduction takes place. At anode, oxidation takes place. Both the processes will occur in single container known as electrolytic cell. Now let us discuss about the products of electrolysis. Products of electrolysis. When molten electrolyte is taken for the electrolysis, products are from its ions only. Students, when molten electrolyte, the electrolyte which is present in the liquid state we are taking for the electrolysis, products are definitely from its ions only. Let us take one example and discuss now. For example, in the electrolysis of molten NaCl, the reaction taking place at cathode, reduction takes place. Charge on the cathode is negative. Reduction takes place at cathode. Cations will migrate towards the cathode. Na plus electron. Gain of electron is called as reduction, which gives Na solid. Reduction takes place at cathode. The reaction at anode is, charge on the anode is positive. Cl minus will loses electron, which gives off Cl2 gas. Cl2, chlorine gas is liberated at anode. Reduction takes place at the cathode. Oxidation takes place at anode. This is oxidation process. So that means, students, when molten electrolyte is taken for the electrolysis, the products are from its ions only. When aqueous electrolyte is taken for the electrolysis, products are may or may not from its ions, may or may not from its ions, from its ions. Generally students, this will depends on the discharge potential. The products of electrolysis, in the case of electrolysis of aqueous NaCl or aqueous electrolyte, the products of electrolysis will depends on the discharge potentials. Discharge potential means the metals which has more negative reduction potentials in the electrochemical series, they need some more discharge energy. Discharge potential is more. Students, for example, if you take lithium, Li plus is present, Na plus is present. So this is, for example, this is having 3.05 volts minus value. This is having minus 2.71 volts. Then in preference to this, Li plus, Na plus will get discharge. Metal which has a more negative reduction potential, this requires a more discharge energy or the discharge potential. So when the two ions, the same ions, this Li plus and Na plus is present in the same solution, electrolytic solution, then instead of Li plus, Na plus will get discharge in this case, right? So this is explained clearly by the preferential discharge theory. Now let us discuss about the preferential discharge theory. Students, preferential discharge theory, preferential discharge theory. When there is a competition, when there is a competition between the ions, in electrolytic solution, the ion which requires less discharge or discharge energy will get discharged in preference to the other ion which requires more discharge potential. Students, already we have discussed about electrochemical series. Whatever the metals they are present at the top of the electrochemical series, they need more discharge potential. Those ions, if you want to discharge, they need more discharge potential, right? Like the order, it is Li plus, K plus, Ca2 plus, Na plus, like middle we have Zn2 plus, then H plus, then Cu2 plus, like that it is their order. This is having more negative, so this is also negative. This is having 0, this is having plus. Okay, more negative, less negative, still less negative value. Negative reduction potential values are decreasing. For example, if both ions are present in the solution, Li plus is present, Zn2 plus is present, more negative value of reduction potential indicates less tendency of undergoing reduction. So it is having minus 3.05 volts and Na plus and Zn2 plus has minus 0.76 volts. When these two ions are present in the solution, electrolytic solution, we are doing electrolysis. Then in preference to the Li plus, Zn2 plus will get discharged, because when the metal it has a more negative value of reduction potential, indicates it has a very less tendency of undergoing reduction. What is the process required to discharge this Li plus? Is to gain one electron, it should convert into Li solid, but it is having low tendency. This value indicates it is a very low tendency of undergoing reduction process. So that's why this is a strong reducing agent. Lithium is a strong reducing agent, not Li plus. So in this, according to the preferential discharge theory, when there is a competition between the ions in the electrolytic solution, the ion which requires a less discharge potential or energy will get discharged in preference to the other ion which requires more discharge potential. So for example, you can understand better when we take this example. Electrolysis of NaCl aqueous. Students, when it is a molten NaCl, only Na plus Cl minus ions are present. But aqueous solution, when we are taking a cathode, the charge on the cathode is minus, negative charge. And here there is a competition. Two ions will come here, that is cation, Na plus will come, and due to ionization of water, because aqueous solution, H plus will come. At anode, charge on the anode is positive. Here two anions will come, that is a Cl minus, OH minus. So there is a competition between the ions here. Then Na plus being more negative reduction potential, it needs more discharge energy. Then H plus will, which requires a less discharge energy, get discharged in preference to the Na plus. So H2 will get. In case of these two, we can compare this. Being a complex ion requires more energy. This is simple ion. So minus electron gives rise to half Cl2. The products we are getting, at cathode it is H2 gas, anode Cl2 gas we are getting, right? So the solution will become rich in the Na plus and OH minus. So if you do crystallization process after doing the electrolysis, then we will get a crystals of NaOH. This method we can use for the preparation of the sodium hydroxide. Students, let us take some more examples for the electrolysis process. Students, when we do electrolysis of NaCl aqueous using cathode is mercury cathode, then product at cathode is sodium instead of hydrogen, because the products of electrolysis, earlier case we have not discussed, but their inert electrodes are used, they are platinum electrodes. Earlier case what we have discussed, that is electrolysis of NaCl aqueous, their platinum electrodes are used. Instead of the platinum electrodes, if you use a mercury cathode, then the product at cathode is Na, sodium instead of hydrogen, right? Because the product of electrolysis also depends on material of electrodes. Here Hg has high affinity towards sodium. That's why instead of getting hydrogen, we will get a sodium. Students, generally electrodes are two types. Inert electrodes active electrodes. Inert electrodes means which does not take part in reaction, cell reaction, we can call it as cell reaction. Which participate in cell reaction is called as active. Which participate in cell reaction is called as active electrodes. Similarly, students, when we do the electrolysis of acidified water H2O, because conductivity is very less for the water, then conductivity can be increased by adding small amount of sulfuric acid. Then the reaction taking place at cathode is negatively charged, right? Negatively charged. So H plus will get discharged to get off H2 gas. Anode, positive charge, anion get discharged into 4H minus, gives rise to 2H2O plus O2 will get, right? 4 hydrogens minus 4 electrons. Loss of electrons is oxidation, gain of electrons is reduction. Students, now let us discuss about the electrolysis of dilute sulfuric acid and concentrated sulfuric acid. Electrolysis of dilute sulfuric acid. Students, reaction at the cathode, charge on the cathode is minus, cation will migrate towards the cathode, cation's present is H plus ion, H plus electron gives rise to half H2. Gain of electrons we can call it as a reduction. Students, when we are taking dilute H2SO4, this will use ionization of water, will use H plus OH minus, and H2SO4 will use 2H plus SO4 2 minus. Then in the case of at the cathode both the cations are same, H plus. Okay, there is no problem. But at the anode, charge on the anode is positive. Then there is a competition between OH minus and SO4 2 minus. Being a complex ion, it won't discharge. Only this will discharge minus, which gives 4OH minus gives 2H2O plus O2 plus 4 electrons. Loss of electrons is called as oxidation. So that means when we try to do the electrolysis of dilute H2SO4, it will become as electrolysis of water. It is not an electrolysis of sulfuric acid, it will become as electrolysis of water only, right? Electrolysis of concentrated sulfuric acid. Electrolysis of cons H2SO4. Ionization which gives H plus HSO4 minus it is giving. So the reaction taking place at cathode is H plus electron gives rise to half H2, right? Reduction takes place. But at anode 2HSO4 minus gives H2S2O8 peroxy disulfuric acid plus 2 electrons it will use. Plus 2 electrons it will use. This is oxidation. So further hydrolysis if you do for this 2H2O which gives 2H2SO4 plus H2O2. This can be used in preparation of the H2O2. That is hydrogen peroxide can be prepared from this. Students, when we are talking about the active electrodes. For example, if you take electro refining of copper, impure copper is taken as a cathode. Negative terminal of the battery, positive. This is negative is small line, positive, negative, positive. This is connected with the one copper rod which is thin in size. Electro refining of copper. This is impure copper. Impure copper, and this is pure copper. Pure copper, which is, this is anode, this is cathode, this is cathode, this is anode. Okay, anode is charge and the anode is positive. So this one is big line, small line, big line, small line. Small line indicates negative, big line indicates positive. Then because of this, what happens if you pass the electricity? What happens? The copper only reduced, copper only oxidized, copper only reduced. At anode, what happens is Cu will loses electrons and it will convert into Cu2 plus. It will dissolve in the electrolytic solution with the time. It will dissolve in the electrolytic solution because of this reaction, oxidation taking place. But here, cathode, what is the reaction takes place? Cu2 plus, which is present in the solution, it will accept the electrons and it will convert into Cu solid. Then with the time, this thickness of this electrode will increases. If this is filled up to this, it is there. With the time, the size of the cathode will increases because of reduction taking place here. Size of the anode will decreases because of oxidation. Here, electrodes also participating in the cell reaction, which is called as active electrodes. The impurities will settle down, which is called as anode mud, right? Friends, this is about the electrolysis process, and the product of electrolysis will depends not only on the electrolytic solution. If it is a molten electrolyte, the products of the electrolysis only from its ions. If it is aqueous electrolyte, then it will depends on the preferential discharge theory. The ion which requires less discharge potential will get discharged in preference to the other ion which requires a more discharge potential. In the case of aqueous NaCl, if we change the material of electrode as a mercury, instead of hydrogen we are getting the product at cathode as sodium, because sodium has high affinity towards mercury. That is the reason why we are getting the product as sodium instead of hydrogen. And when we are doing the electrolysis of dilute H2SO4, it is not electrolysis of H2SO4, it is the electrolysis of water we are getting. So product at cathode is hydrogen, product at anode is oxygen gas we are getting. So in some cases, the electrodes also participate in the cell reaction. They are called as active electrodes. We have discussed, that is in the case of electro refining of the copper. So copper anode, copper cathode are used. Size of the anode is more, size of the cathode is less, thin it is. With the time progresses, thickness of this will decrease because this is dissolving in the solution. Thickness of the cathode will increases, and whatever the impurities present, it will settle down at the bottom of the container, right, which is known as anode mud. So in the next video, we are going to discuss about the Faraday's first law and second law. Thanks for watching.